Good morning, or good afternoon, or good evening, whenever you're watching this video. Um, this is the first new assignment of the fourth quarter. Although I'm putting this video up, I want you guys to view it. I want you guys to view it and try to learn the content. I have posted the notes both on Google Classroom and on Blackboard. First and foremost, remember that April 24th is the deadline for any review that you need to do before the end of the third quarter. All right, now with that said, so what I'm saying is finish everything you want to do for third quarter first and then start these notes. Okay, so first thing we're going to do is this is Unit 7, Part 2, factoring trinomials. Okay, so what is factoring? Factoring is the opposite of foiling. So here, if we were to foil, right, we would do our box, and we would do x here, right, for x, and then minus 3. So then that would be x squared minus 3x. That would be 4x, and that would be negative 12. Remember, when you're multiplying a number and a variable, you just put them together. On the diagonal, you have the like terms. So you have x squared minus 3x plus 4x minus 12. Come on. Then you're going to combine the like terms. So we have x squared plus x minus 12. Sorry about that. I'm still getting this new technology down. All right, so there, that would be your answer. When you factor, you want to take this answer and turn it into that. Okay, we're going to take something that looks like this and turn it into two sets of parentheses. To do that, there's a process. Let's just go straight to the process. First thing you're going to do is you have to remember that this is A, this is term A, this is term B, this is term C. To solve this, you're going to do A times C. So here is going to be A times C, right? That's what's going to go there, A times C. What would that be, right? So I'm going to draw this over here. So that's going to be what we're doing, A times C, and then this is going to be the B term. So A times C, what letter or what number represents the A here? It's going to be 1, right? So 1 times 3. 1 times 3 is equal to 3, right? So this is going to be here. This is very important. Always create a T-chart, do A times C, and give the product here. Then just simply take the term B. You have to take the sign in front. So that's going to be 4. Now, what you're doing here is seeing two things. This side is multiplication, this side is addition. So you're going to see that what numbers multiply to 3, right? So you have 1 times 3, you have negative 1 times negative 3, and then you say, do these numbers add up to 4? So these are the only two numbers that multiply to 3. Now you need to see which set of these numbers equal a positive 4. So now you do 1 plus 3 equals 4. So this set of numbers, 1 and 3, satisfies this T-chart. We're looking for a set of numbers that will multiply to 3 and add to 4, right? This does multiply to 3, but if we do negative 1 plus negative 3, that equals negative 4, so that doesn't work. Let's say you don't know what numbers multiply to equal what. Where can we always go? Always go to, you got it. Let's see if I can get there quick. Math space, not math space. Always go to decimals, right? Always go to decimals. So now we say, well, 1 times 3. Let's say we forgot what multiplies to 3. You do 3 divided by x. Come here, you create your chart, your table. Now, these are all the numbers that multiply to 3, right? 1 times 3 equals 3. Negative 1 times negative 3 equals 3. Remember, you do not want to deal with the decimals. So, only whole numbers. And when they start to repeat, you you know that you have exhausted all possibilities. So if you see here, we had -1, -3. Then we had 1, 3, and then it repeated and did 3 and 1. That means there's no other whole numbers that will multiply out to 3. So once you find what multiplies to 3, you then need to find what adds to 3. Once you find what multiplies to 3, you need to figure out what adds to 4. And we did that here. Why is that so important to us? Because what we're really doing is splitting up this term here. What do I mean? We're splitting up this term. We're going to rewrite this with 4 terms. How did I split this term up? I split it up with 1x and 3x. Well, where did 1 and 3 come from? 1 came from here, 3 came from there. So I split b. I'm splitting b, and that gives me x squared plus 1x plus 3x plus 3. Now that we're here, you guys like the box method, so we'll go back to using the box method. Here we go. We're going to take those terms and put them in the box. So x squared will always, or the first term, will always go into this box. So x squared will go here. The second term and the third term doesn't matter where you put them. The fourth term has to go here. So first term, last term. Where you put the x and the 3x, it doesn't matter. So you can put the x here, or you can put the 3x here. Now what I'm going to do is create another box over here and show you that it does not matter how you set these up, as long as you put the x squared here and the 3 here. Let's say we put the x here and the 3x there. Now, what you're going to do is factor. You're going to factor from left to right, and from top to bottom. Your answers will go on the outside. So I'm looking from left to right now. What can I take out of x squared and x? Well, there's 1x here and there's 1x there. So I'll just take an x there. What can I take out of 3x and 3? Well, I can take a 3 out of here, and I can take a 3 out of here. So that would give me 3. Now it's just going to be a positive and negative. Well, because both of these are positive, that answer is going to be positive. Now here we have to go vertically. We went horizontally, now we have to go vertically. Well, what can I take out of x squared and x? Well, I can take out an x from here and an x there, so that would take out an x. And what can I take out from x and 3? These two terms don't have anything in common, so I'll just put a +1. And these are your answers. So your answer would be x plus 1 and x plus 3. Now remember, we said we were going to take a polynomial and break it down into 2 terms. That is how you break down, or that is how you factor a polynomial. It is a lot of steps, but you guys will get into a nice rhythm. All right, so I know that's confusing. I know you probably have a lot of questions. What we're going to do is do B together. Remember, these are just notes right now. So we're just going to work through the notes, and we're going to make sure we get everything done. If you need another sheet of paper to work on, or a notebook paper, maybe you printed out the notes and you don't have enough space, remember, you can always add to your notes with loose leaf paper to help you understand better. All right, so let's look at letter B. The first thing you have to do is pull out the GCF. This one didn't have a GCF. Whenever that's a 1 there, it's not going to be GCF. Whenever you have a term in the front that's not 1, you always check to see if there's a GCF. Meaning, is there a number or letter that can come out of each term? We have a 2 here. Because this is even, a 2 can come out. Because this is even, a 2 can come out. So what you're going to do is you're going to divide each of these by 2. You guys remember doing this? So now when I take that 2 out, right, that 2 cancels out. I have a 2 here. I can't take out an x from each one because there's not an x at each term. So what's left over is x squared minus 16 divided by 2 is 8x plus 15. All right, now we're here. Now there's no more greatest common factor. So now what we have to do is do our A times C. This 2 is just going to hang out. It's just going to hang out. Don't forget it. Now, here we go. We make our chart. We have A times C here, and we just have the number of B here. So A times C, that's 1. 1 times 15, so we do 1 times 15, and that gives us 15. A times C is 15, and then just B. So B is just -8, so it's just -8. So what we're looking for is numbers that multiply to 15. Well, there's a couple of numbers that multiply to 15. So you have 1 times 15 and 15 times 1. Typically, it's not going to be those, but we'll just write those down. 1 times 15, -1 times -15. What else do we have? We have 3 times 5, and we have -3 times -5. And you just go through. Does 1 times 15 equals 15? Yes, that works here. But what is 1 plus 15? That equals 16. Does 16 equals -8? Nope. That's gone. That's not an answer. Now you go to the next one. Does -1 times -15 equal 15? Yes, because a negative times a negative equals a positive. Does it equal -8 when you add it? So let's try. -1 plus -15. Well, that equals -16. So that doesn't work. All right. Okay. 2 are gone. We got 2 left. So now we have 3 times 5. That equals 15. Perfect. But what is 3 plus 5? That equals +8. We're almost there. That doesn't work. So now we do -3 times -5 gives me a +15, and -3 plus -5 equals -8. That is the answer. So your answer, you're going to split this up, right? X squared, you're going to split B with -3x minus 5x plus 15. From there, you're going to use your box method. It's a lot of drawing. It's a lot of work, I know. I'm going to redraw this and give us a little more space. A little more space. That wasn't good. Alright, so let's come down here a bit. So now we split the box. Remember I said it doesn't matter where these go or on here. It's just the first has to go in the first and the last has to go in the last. So we'll have x squared here. We'll have -3x. We'll have -5x. And we'll have 15. Remember, now we're going to factor. You're going to factor horizontally, and you're going to factor vertically. So horizontally, we're only going to look at these two. What can we take out of x squared and -3x? Well, there's an x here, and there's an x there. So I can take out one x. I can only take out one x because there's only one here to take out. So we just take out an x. Now, going from left to right or horizontally, what can I take out of -5 and 15? Well, 5 goes into 5, and 5 goes into 15, so I'm going to take out the 5 here. What you have to remember is if this term is negative, then that 5 has to be negative. Okay? Now, what do we do here? We go here and we see what's going on vertically. We see that there's an x here and an x there, so I can take out an x. No, there's not x's I can take out here, but 3 does go into 15. So now we know that that's going to be a -3. Whenever this term is negative, that has to be negative. Whenever this term is negative, that has to be negative. So now let's go ahead and write our answer. 2 times x minus 3 times x minus 5. That's your answer. It is a lot of work, I know, but there's a process that we do every single time. Doing this process will help you. Let's look at C. So remember, is there anything we can take out of each term? 1, 2, 3. No, there are A's we could take out here, but there's no A here. 1, right? We're not going to take out from 2 and 10, so there's nothing to factor out here. All right. Remember, how could we figure that out on Desmos? Remember greatest common factors on Desmos? Let's go back and see. So if we have here, we do GCF. We just type in GCF, open parentheses, and we just put in a number 1, comma 2, comma 10. If that equals 1, that means there's no greatest common factor. Now, let's go back up to the problem we had just done. Go to Desmos, and you put in 2, 16, and then 30. What you will see is that the greatest common factor is 2. And I just did that in my head, but you guys, I know sometimes it takes you a while to figure it out. Go ahead, cut that extra time out, put it right in the Desmos. Um, use the tools that you are given to be as successful as you can be, right? All right, so we're here, and we're working with a squared. We found out that there's no GCF, so now we have to set up our chart. Our chart means what? What is here? We're going to do A times C. This is our A, that's our C. So 1 times 10 gives you 10. And then we're just going to take the value of B, which is 2. So now we're looking for something that multiplies to 10 but adds to 2. So now we go 10. The multiples of 10 is 1 times 10. Negative 1 times negative 10. 2 times 5. And negative 2 times negative 5. What we find here is 1 times 10 is 10, but 1 plus 10 is equal to 11. Negative 1 times negative 10 is 10, but negative 1 plus negative 10 is equal to negative 11. 2 times 5 is 10, but 2 plus 5 is equal to 7. And then we have negative 2 times negative 5, and then we have negative 2 plus negative 5. That also equals negative 7. What you're going to find here is that this is a prime factor. There is no set of numbers that multiply to 10 and add to 2. So we would just write prime here. That can happen. I will say on your tests and your quizzes, we're not going to give you prime, right? We're going to do our best not to give you a prime number. All right, so here we have another one. But this is important to see that sometimes there just is nothing that satisfies both. So here we have A times C again. There's nothing that comes out. When that's a 1, there's nothing that comes out. So we'll do A times C again. A times C is 1 times 6. That's going to give us 6 here. 1 times 6. And then we have just the value of B, which is 5. So now we do 1 times 6. Negative 1 times negative 6. 2 times 3. And 2, negative 2 times negative 3. And we just go through 1 plus 6 equals 7. That doesn't work. Negative 1 plus negative 6 equals negative 7. That doesn't work. 2 plus 3 does equal 5. Bang, 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 bang. That's it. So now we're going to break the middle term down. And we're going to do 2xy plus 3xy. Alright, so now we're going to rewrite that. X squared plus 2xy plus 3xy plus 6y squared. Remember, we're going to create our box now. When you create your box, the first term goes into the first box, x squared. The last term goes into the last box. And then these two, it doesn't matter. So now left to right. What is in this term and in that term? X. So we just take out the x. All right, here, what's in this term and in that term? So we see that 2 and 6 are both even. Remember, you guys, if you're getting to the point where you cannot factor, or you just forget how to factor, or you just want to make sure you're not making any mistakes, remember, always go Desmos, just type it in, GCF, and then go 2, comma 6. Your answer would be 2. All right, so we're gonna knock this down here. We can take out a 2, but we're not done. We can also take out a what? A y. There's a y on each of these, so 2y would come out. We can take out an x here, and what can we take out of here? Well, 3 and 6, I can take out a 3, and I can take out a y. So your answer is x plus 2y times x plus 3y. That's how you would knock that down. Well, ladies and gentlemen, those are the first 4 problems that you have to do. All right. Um, let's see how much time we're at. We are at, right now it's 20 minutes. If you guys want to stop, you can stop. I'll just do E one more, just one more. I'll just do E, and we'll move on from there, and that would be the end of the video. So with this 3, put the numbers in decimals. Okay. So we're just gonna go to decimals. Knock this down real quick. Where's my decimals? There it is. And what were the numbers we were using? And here, here. We were using 3, 11, and 6. So we'll just go 3. No GCF because it came out of 1. Alright, which means that we're just going to go straight to A times C. So we'll write our chart here. Remember over here, A times C, and then B is just by itself. You're going to each always use those 3 terms. 3 times 6 is 18. The term for 11 is B. So now we're looking for the factors of 18. I'm just going to go through this one using all decimals, okay? So I need the factors of 18. How do I get that? I do 18, and then what do? I do divided by x. I know you guys are answering those questions. So we're looking for the factors of 18. All right, so we have 1 and 9. We have 1 and 18, 2 and 9, 3 and 6. And then it becomes decimals, and then it repeats. So these are the 3 we're going to use right here. So we're going to use 1 times 18, 2 times 9, and 3 times 6. 1 times 18 does give me 18, but 1 plus 18 equals 19. 2 times 9 does give me 18. 2 plus 9 does give me 11. Just go through, and 3 plus 6 equals 9. So the only one that works is 2 and 9. Alright, so now we're going to split the middle. Remember, we split the middle. Now this becomes 2x. That becomes plus 11x. We rewrite it. 3x squared plus 2x plus 11x plus 6. Then we create our box. We have 3x here, 6 here. Then we go 2x, and we go 11x. Remember, we go horizontally, we go vertically. This is x squared. So now, horizontally, I can't take out 3 and 2. There's nothing there that's the greatest common factor. Just to check, I go GCF, 3, comma 2. It's a 1. That means I'm only going to be able to take out a variable. If I can take out a variable, that just goes here, and I just take out an x. Here, horizontally. 11 and 6. Let's see. Well, is there anything? I know 12, but what about 11? 11 and 6. Nothing. It's just a 1. Okay. But can I take out an x? I can't take out a number or a variable, so what do I put there? I put a placeholder of a 1. So I come back here, and I just put positive 1. Now here, straight up and down, vertically, I can't take out 3 and 11. Let's make sure 11, comma 3. That's a 1. So I know that I'm only looking for variables now. I do see that there's an x squared and an x. I can take out a 1x. Now here, I have 2 and 6. Let's put that in there and see what happens. What is my GCF? 2, comma, 6. That gives me a 2, so I can take out a 2. Now, can I take out an x? Nope. Is that going to be a positive or negative 2? Well, that's a positive 2, so that's going to be positive. That's a positive 11, so that's going to be positive. So you guys have done it. Your answer is x plus 2, and then x plus 1. All right, you guys, thanks for hanging around. Go ahead and go over these. I'll also put up a math space for you guys to do as well to help practice. All right, I hope you guys have a good day. Bye.